For page 333, hopefully on the email I explained everything. Again, just send me a picture of this by text or by email or some way to show that you have it, and I'll mark it off in the grade book. I'm going to go through the answers. You can do with them what you want, just to check your answers or whatever you need to do. Number one says, the blank of a triangle is a segment that connects the midpoints of two sides of a triangle. That was the whole main topic, the big idea of that lesson, and it was mid-segment. And I'm going to go fairly quickly on these because I'd like to keep the video less than 30 minutes for sure. Number 3, find the coordinates of point D, E, and F. D, E, and F over here. We're going to find those coordinates. And we could find the coordinates just by looking at the graph here, but we're going to use the midpoint formula. And I've already went through and figured out what the coordinates for A, B, and C are. They tell us that each of those is a midpoint. In the directions they say use the graph with mid segments. They actually tell us that each of these right here is a mid segment. So D has to be a midpoint, E has to be a midpoint, F has to be a midpoint. And again, we could just count on the thing, but I'm going to actually use the formula so you can see how to use the formula again. For A, segment AB, we want to find the midpoint, so I'm going to use those two ordered pairs there for segment AB, and that's going to give us coordinates for E. Our formula is the x's, so -5 plus 1 divided by 2, and then the y's are 2 plus a -2 divided by 2. Let me know by email or whatever, because sometimes the audio doesn't work real well at the beginning of these videos. So if that's still occurring, just let me know, and I'll try to adjust to it. We do the math here. -5 plus 1 is -4. -4 divided by 2 is -2. On this one, 2 plus a -2 is 0. 0 divided by 2 is 0. That's the coordinates for point E. So that's one of our answers. Next one, we'll do segment AC. So for segment AC, we're going to use A, and we're going to use C here. We got -5 plus a -3 divided by 2. That's our x's. Then our y's are 2 plus a -6 divided by 2. Do the math here. -5 plus a -3 is -8. -8 divided by 2 is -4. 2 plus a -6 is -4. -4 divided by 2 is -2. And that's the coordinates for point D. That's right here. And we could go over here and check and make sure that we're doing it right. 1, 2, 3, 4, 1, 2. So we're left 4, down 2. It looks like we're doing them right. Then the last segment I'm going to find the midpoint of is segment CB. So we're going to use C and B. Our x's this time are -3 and 1. So -3 plus 1 divided by 2. Our y's, -6 and -2. So -6 plus a -2 divided by 2. -3 plus 1 is -2. -2 divided by 2 is -1. -6 plus -2 is -8. -8 divided by 2 is -4. That's the coordinates for point F. Number 4 says show that DE is parallel to CB and DE is half of segment CB. So we want to show that the two are parallel, and we want to show that one is half the length of the other. I'm going to erase some of this so that I can have a little more room here for number 4. So first thing on number 4, to prove or to show that DE is parallel to CB. So we're trying to show that these two are parallel. What we can do is we can find their slopes. So we can find the slope of DE. Slope of DE right here. All we do is count our rise and our run. Looks like we go up 2 and to the right 2. So we go up 2 to the right 2, which is the same as just 1 over 1. Segment CB, we can do the same thing, rise over run. We go up 1, 2, 3, 4, up 4, and to the right 1, 2, 3, 4. So we go up 4 to the right 4, which reduces to 1 over 1. Since these are the same, both the same, that means their slopes are equal, and if slopes equal, then that tells us that the lines are parallel. Their slopes are the same, then the lines are parallel. The second thing that they want us to do is show that this length is half as much as that length. And the way we're going to do that is we're going to use the distance formula to find each length. You might need to have your calculator for this. Your distance formula, remember the distance formula looks like this. It's the x's subtracted, then a plus in here, and then the y's subtracted, and you square it. Remember, it's subtracting inside the parentheses, plus in between the parentheses, and you got to square each thing. So for segment D and E, we need the coordinates for points D and points E. Point E, it's left 2, so that's a -2, 0. Point D is left 1, 2, 3, 4, so -4, and down 2, so -2. And we're just going to do a little math here. It's -2 minus a -4 squared plus a, for our y's, 0 minus a -2 squared. Change these to plus whenever you have the two minuses right there next to each other, or a positive or a negative and a minus right next to each other. We do a little math. -2 plus 4 is 2. 2 squared is 4. So that first part here is just 4. 0 plus 2 is 2. 2 squared is 4. And we end up with the square root of 8. Take your calculator, find the square root of 8, and it comes out to be somewhere about 2.83. Now we want to do the same thing for segment CB or BC, whichever way you name it. This time we got our x's are -3 and 1, so I'm going to go 1 minus a -3 squared plus our y's are -2 and -6. So -2 minus a -6 squared, change that to a plus, change that to a plus. This first part, we got 1 plus 3, that's 4. 4 squared is 16. So for the first part there, we got 16. For this second part, -2 plus 6 is 4, 4 squared is 16. So we got 16 again, that's 32. We want the square root of 32. So we grab our calculators, second square root 32, and we get about 5.66. Well, if we, what we're trying to show is that this one, that mid segment is half as long as this one. And if you take 2.83 on your calculator and times it by 2, you get 5.66. So that shows that this top one is half of the bottom one down here. Next one, number 7. 7, 8, 9, and 10. On number 7, they're telling us that segment DE in each one is a mid-segment. Well, on the first one, we have a triangle that looks something like this. Mine might not be perfect, and this is DE, and they're telling us that that's X, and this is 26. Ignore any of those stray marks that go up through there like that. Well, we know that this mid-segment has to be half as much as that, so the answer to number 7 is just 13. Just take half of it. Number 8, triangle looks something like this. Segment DE is here, and they tell us it's 5, and X is right here. This is the mid-segment this time. We know it's got to be half as long as this side over here that it's parallel to, so all we do to the 5 is times it by 2. 5 times 2 is 10. That means X has to equal 10. Number 9. Number 9, they give us something that looks like this, and DE is here. That's our mid-segment. And they tell us that this is 6. Well, if this is 6, X is right here. If this is a mid-segment, then that's got to be a midpoint. And if that's a midpoint, that means that these two segments have to be congruent to each other. So X has to equal 6.
Staff, am I going to put his attention first?
This time, number 10, they tell us this is a mid-segment. If that's mid-segment, then that's a midpoint. And so if this is 8, that means this has to be 8, so X equals 8. Next one, they give us this and they tell us that segment, they give us a picture, it looks something like this on 11 through 16. And they tell us that XJ, segment XJ is congruent to segment JY, and they tell us that segment J or YL is congruent to segment LZ, and then they tell us that these two segments are congruent to each other. So that means each of these points, J, L, and K, are midpoints, and if they're midpoints, then each of these segments is a mid-segment. Number 11, they want to know that segment JK is parallel to what segment? Well, if we find segment JK, that's right here. Well, it's got to be parallel to this side of the big triangle over there, which is segment YZ. So that's your answer for number 11. Number 12, I'm not going to write down all these every time. Number 12, they say segment JL. Segment JL is this segment. Well, it's got to be parallel to segment, this bottom side of the triangle, so segment XZ. Number 13, segment XY. Segment XY is this side of the big triangle, and it has to be parallel to segment, the mid segment, segment LK. 14. They say JY, I'll write this one out. Segment JY is congruent to, and then they want two other segments. So we look at segment JY is right here. Well, we know since J is a midpoint, it's also going to be congruent to JX right here. So segment JX is one of our answers. And then since it's these two are congruent, this one and this one, and this is the mid segment that goes along with that side, we also know that both of those segments are congruent to segment LK. So not only are these two congruent, but it's also congruent to that one right there. And we could do the same thing on the rest of these. These bottom two have 3 tick marks on them. Well, they have to be congruent to that one right there in the middle. These over here have 2 tick marks on them. Well, they have to be congruent to that one. And that's probably where questions 15 and 16 are going. Question 15 says segment JL, which is right here, and it has to be congruent to XK and KZ. So segment XK and segment KZ. So those are your two answers for 14 there. Those are your two answers for the blanks in 15. And then 16, segment JK. Segment JK is right here. Notice we marked it with 2 tick marks. Well, it's congruent to these two out here, then segment YL and segment LZ. Segment YL, segment YL, and segment LZ. So those will be your two answers on number 16. (17) through 19. Each one uses a little different thing, so I'm going to use this one picture. We're going to label stuff, and then I'll erase it after each one. 17 says segment AB is 3x plus 8, so I'm going to label that in here, 3x plus 8. Segment GJ, that's this whole segment down here at the bottom, is 2x plus 24. Several different ways that you can do this. So it's up to you how you do it. We know that segment GC has to be the same as segment CJ because C is a midpoint. And we also know that this segment up here has to be half as long as the whole thing. So we know that it's also congruent to those two. So what we could do is we could take the bottom part, the longer of the two, and split it in half. Or we could take this, the mid segment, and double it to get it. Sometimes it's easier to do one, sometimes it's easier to do the other. Just depends on the problem. If all these are even numbers, then we could just take half of this. So if I take 2x plus 24 and I take half of it, so I'm just going to divide each thing by 2. That means I get x plus 12. That means each one of these segments is x plus 12. Well, it also means that, or we also know that this segment and this segment have to be equal to each other. So we could set up the equation 3x plus 8 has to equal x plus 12. Now, other times it might be easier to take this top one and double it and set it equal to that whole segment down there. It just depends on the problem. So here I'm going to solve this, end up with 2x plus 8 equals 12, subtract 8, end up with 2x equals 4, divide by 2, and I end up with x equals 2. On these problems, it says use triangle midpoints to the sides. They want to know on this problem, on number 17, they want to know how long segment AB is. So once we know x is 2, we're going to take that 2 and we're going to stick it right back in there. So it's going to be 3 times 2 plus 8. You can plug all that right into your calculator if you wanted, or just do a little bit of math. 3 times 2 is 6. 6 plus 8 is 14. So our answer for 17 is 14. Number 18. Problem 18, it says segment AC is 3y minus 5. So that's this segment right here. 3y minus 5. And HJ is 4y plus 2. So this whole segment out here is 4y plus 2. Again, we could take half of this and set it equal to the mid segment, or we could double the mid segment and set it equal to that. This time I'm going to double the mid segment. So if I double that mid segment, that means I'm taking that 3y, that should be 3y minus 5, and I'm just going to times everything by 2. So that gives me 6y minus 10. So that should equal that whole side of the triangle. So 4y plus 2 should equal 6y minus 10. And you can do it either way. You can take half of the longer one, half of the side of the big triangle, and set it equal to the mid segment, or you can double the mid segment and set it equal to the whole thing. Here I solve this, subtract 4y on both sides. I end up with 2 equals 2y minus 10. Add 10 to both sides, and I end up with 2y, ignore that, those cancel out, equals 12, divide by 2, and you end up with y equals 6. This time they ask us to find segment HB, so we want to find the length of segment HB. HB is just this part right here. So several different ways we could find that. We know that this segment, and this segment should all be congruent, so we could just find this segment, and that's going to be the same as HB. We could plug in right here for y and take half of the answer we get, and that's going to be segment HB. It makes no difference. I'll plug in to this one right here and do it that way. So if I plug in 6, end up with 24 plus 2. 24 plus 2 is 26. We don't want that whole thing, we only want half of it. So we just want half of 26, which is 13. So HB has to be 13. Segment AC also has to be 13. Segment JB also has to be 13. All three of those end up being 13. Number 19, they tell us that segment GH is 7z minus 1. So GH, that's this whole thing, 7z minus 1. And they tell us that segment CB is 4z minus 3. CB, that's right here, is 4z minus 3. Supposed to be a z. This time, if we try to take half of 7z minus 1, it doesn't come out real well. So this time we probably want to take this one and double it. So 4z minus 3, and we want to multiply it by 2. Double it. That'd be 8z minus 6. And we know 8z minus 6 should equal this whole segment out here, which is 7z minus 1. So 8z minus 6 has to equal the whole thing, which is 7z minus 1. We solve this, end up with z minus 6 equals a negative 1. Add 6, end up with z equals 5. On 19, they ask us to find the length of segment GA. Well, segment GA is this right here. Again, we know that this segment, and this segment are all the same. So I'm gonna plug into this one. So 4 times z was 5 minus 3. 4 times 5 is 20. 20 minus 3 is 17. So segment GA has to equal 17. So that's 17. Well, then that HA would have to be 17, and BC would also be 17. Number 20 says describe the error, describe and correct the error. If we look at that, it says DE is 1/2 of BC, so so that has to be a triangle mid-segment. Our triangle looks something like this, and we got this going across here, and it says this is 5, this is 10, and it's true that this is half as long as this. But when we're going backwards, when we're using the converse of that theorem, where we said if this is a mid-segment, then the mid-segment's always going to be half as long as the side of the triangle. Going the converse of that, it says if this segment is half as long as this and is parallel to it, then it's a mid-segment. Well, this time they didn't tell us that that was parallel, so we must the mid-segment and the side must also be parallel. If you just wrote that answer down, it's got to also be parallel. Problem 21. Problem 21 says the distance between consecutive bases on a baseball field is 90 feet. A second baseman stands halfway between the first baseman and first base and second base. Shortstop stands halfway between second and third base, and a pitcher stands halfway between first base and third base. Find the distance between the shortstop and the pitcher. So on this, and I know all this isn't true, the shortstop doesn't always stand exactly halfway in between second and third base and so on and so on. So it's not exactly true, but they're giving you some idea on this one. We know that this distance from here to there is 90 feet. We know that this distance from here to there is 90 feet. Well, if this is a midpoint, this is a midpoint, all right, then, and we know this is a midpoint. They told us all that, so all these are mid segments. So we know that the distance, we want to find the distance from the shortstop, I think is what it said, to the pitcher. So we're trying to find that distance right there. Well, if we look over here, we know that since this is a mid-segment, this segment and this segment have to be parallel to each other, and the mid-segment, this one, has to be half as long as that. So the distance from the pitcher to the shortstop should be half of 90, which means our answer is 45 feet. And then the last problem, I believe, was 25. Problem 25 says, to create a design shown, shade the triangle formed by the 3 mid-segments of the triangle. Then repeat the process for each unshaded triangle. This is just to get you to think a little bit. Part A. Part A, they want us to find the perimeter of this triangle, the shaded triangle here, the mid-segment triangle. If each side's 16, we know the perimeter of this one's 48. If you take 3 times 16, that's 48. So we know that perimeter. They want us to find this perimeter. Well, if we look at this, remember that if this is a midpoint, then this is 8, that's 8, that's 8. Well, this mid segment's also 8. And then it's gonna work for all the others, so that's 8, that's 8. Well, the perimeter then is 3 times 8, which is 24. Stage 2 down here. Well, that's the answer, so this is 24, that's the answer to part A. Part B says, what is the total perimeter for all the shaded triangles in stage 2? So if we look at this one, we already know that this triangle has a perimeter of 24. And if you look at this, if this perimeter was 48, this perimeter was 24, then what's happening each time is the perimeter is going down by half. So the perimeter of each one of these little shaded ones would be 12. That one's 12. That one there is going to be 12, and we just add all those up to get the total perimeter. So 12 plus 12 plus 12 plus 24. 12 plus 12 plus 12 plus 24, and I know there's probably an easier mathematical way for you to do it. You do it however is easiest for you. 12 and 12 is 24, plus another 12 is 36. 36 plus 24 is 60. So the answer to part B is 60. Part C, notice on part C I wrote, yeah, right, not much chance that I can draw that, but we can just look at it out of the book, and we know the big shaded triangle is 24. We know that the 3 next size triangles are each 12. We just got those in the last part. And then we're going to add on all the little bitty triangles that they drew there that are shaded. And there is 1, 2, 3, 4, 5, 6, 7, 8. There's 9 of them. So it's 9. Well, if the last triangles were 12, it's going to be half of that, so it's going to be 6. 9 times 6 is 54. And we're just going to add up all of those. So those little bitty triangles, there's 9 of them, and each one has a perimeter of 6, because we're taking half of it, so we just add all that up. Well, we already added up 24, 12, 12, and 12. That was 60, and now we're just going to add on the 54. 60 plus 54 is 114. That should be our answer. 114 is the perimeter of all the shaded triangles in stage 3. Stage 3. So again, that's page 333. That's one of the assignments that we said was due. Sorry, I went a little over 30. Send me a picture of it. You know, try it. Make sure you're trying it. I can't do a whole lot about it if you just cheat and copy everything down, but I actually, you know, we want you to learn something, so make sure you're trying it.